Our disk consists of a circle that's actually been filled in. So now we're gonna, I'm not gonna actually fill it all in, but I'm gonna imagine it has been, and then we're gonna take a sector out. We don't know how much, but some amount like this, making two straight cuts from the circumference to the center. We don't know the radius, so I'm just gonna work in terms of r. So both this and this are r. And we're told that the perimeter of the sector has the same length as the circumference of the original disk. Well, that can be easily found. The circumference is pi times d, or 2 pi r. And then I'm going to consider the sector separately, r, and so I just want to find this length. Now, I'm going to introduce theta into this. That is just the angle of the sector, and it's going to be the same here, which means that the length, the arc length here is actually the fraction of the circle that we have with the sector, which is theta over 360, and then I'm going to times that by 2 pi r. And here's one other thing. That is the fraction of the circumference that the arc length has. Actually, it's also the fraction of the area that's removed, because the whole area is pi r squared, and then this is theta over 360 times pi r squared. So in fact, that's what I want to find at the end of everything. Now the perimeter for this sector is therefore going to be, we're walking around it. So I'm going to start here, and I'm going to walk to the left. So it's r plus this expression here, which is going to give me 2r plus theta over 360 times 2 pi r. Okay, I've set everything up now. We're told that the circumference is equal to this perimeter. So 2 pi r equals 2r plus theta over 360 times 2 pi r. And all I need to do is make this theta over 360 the subject. I can do that by, first of all, just dividing through by r. This fraction is going to be the same whatever the radius is as I make the circle bigger and smaller. And then I can also divide through by 2, which is going to leave me 1 here and that. So that means that theta over 360 times pi is going to equal pi minus 1. And theta over 360, the fraction of the circle that I'm left with when I've removed this sector, is going to equal pi minus 1 over pi. That's my final answer.